Hi everyone, let's solve today's daily challenge, that is search insert position. So in this question, we are given a sorted array of distinct integers and a target value, and we have to return the index if the target is found. If not, we have to return the index where it would be if it were inserted in order. So we have to write an algorithm with O log n runtime complexity. So as we can see, we are given a sorted array and we have a target value. So we have to simply search, right? At whatever index this particular target value is present. And if it is not present in the array, right, then we have to tell what index we need to insert it, right? So that the array is still sorted, right? So this is nothing but binary search, right? The only thing that we have to do extra is to return this index, right, where it would be inserted. Otherwise, in binary search, we just check whether that particular element exists or not. If it does not exist, we simply return -1, right? So first, let's see how binary search is done, right? So let's see. Let's say we are given an array like this. We are given 1, 2, 3, 4, 5, 6, and 7, right? This is the array that is given to us. Now what binary search does is it takes a mid value, right? It takes a mid value. So let's say here we have a low pointer which is initialized to 0. Here we have a high pointer which is initialized to the last index of this array, which is 6, right? Now what we will do, we will find a mid value. How? We will just add these two indexes and divide them by 2. So what we will get? We will get 3. So 3 will be our mid value, right? So the mid value is what? Here we have our mid value. So now let's say we want to search for 2 in this array, right? This is the target value, right? So we have 4 here. Now now we will check whether the mid that we have got, right, if it is equal to the target value or not. So we can see that this target value is not equal to this mid. Now as the array is sorted, right, so binary search only provides the idea that we can reject one half of this array, right? That is because our target value is smaller than this mid and our array is sorted. That means all the values to the left of 4 are less than 4 and all the values to the right of 4 are greater than 4. So as the target value is less, right, so we can simply reject this part, that is the right part. So now our array will become this. So what will we do? We will make our high pointer point to this position, right, which is this is the mid, right? So our high becomes mid -1, right? So we are here, our high is here. What is the value of high now? High will become 2, right? Now we will again do the same thing. We will again calculate a mid for this particular array, right? So how do we calculate the mid? As we saw, low plus high by 2, which is 1, right? And then our mid is pointing to this position, and we see that this value is equal to this target value, right? So as this value is equal to target, that means this is the position that we needed, right? So we will simply return mid in this case, right? But now let's see. So this is the simple binary search, but we also have to calculate, let's say an element is not present inside of this array. So we have to find the location at which we will insert that element so that this array remains sorted, right? So let's see. Let's take another example. Let's rub all this. Okay, let's move above. All right. Okay, let me take another 10. Okay. Now let's take another array. Let's say we are given 1, 3, 5, 7, 9, 11. Right? We are given this. Let's also write their index. Right? So these are the index. Now, let's say our target value was 4. Right? Let's say our target value was 4. Okay, let's not take 4 here. Let's take 8. Right? Our target is 8. Now let's see how we will search for this. Now one thing is clear that if we want to insert this 8, right, we will be finding a position, as you can see in this array, that is 8 will go after 7, that is at this position, right? So 8 will go to the position which is just larger than 8, right? So that is 9. So we will be inserting 8 in this position, and 9 will be shifted here and 11 will be shifted here. So I guess this is clear, like where we will be inserting 8. We will be inserting 8 to just the upper bound of 8, right? Just one, that is a value just higher than 8, that is inside of this array, right? So let's do the same thing. So in this case, what we will do, so if we don't get a mid, what we'll be doing is, first let's have our low pointing to 0 and our high pointing to last index. Now what we'll do, we'll again find the mid, right? So what will be the mid in this case? 5 plus 0, 5 plus 0 by 2, which is 2, right? So this is the mid. Now we can see that this is not equal. Now what we will do, we will check, right, which half of the array we have to go. So as this value is greater than the mid, then we have to move towards the right part, right? So how do we move towards the right part? We should make our low point here, right? So we'll say low is equal to mid plus 1, right? So we'll move to this particular index, that is 3. So now low is 3 and high is still 5. So now again we will calculate the mid, which is 5 plus 3 by 2, which is 4, right? So our mid is this particular value, which is 4. Now as I said, what we'll be doing is, at this position, right, we can see that this value is greater than 8. What we will do is, we will have an answer variable and we will store this particular value, right, 4, inside of this answer variable. And then what we will do, we will move towards the left part, right? Because in this case we are not going to find 8, but what we saw, that we have to insert this 8 at the position which is just, greater than 8, just greater, right? So right now it's pointing to 4. Now we will do what? Because this value is greater than 8, right? So we should move towards the left. And similarly, towards the left also, we will do the same thing, right? We will try to find a number which is yet, is greater than 8, but less than this particular mid, right? Let me take another test case so it will be more clear. Let's take another test case, right? Let's say we have 2, 6, 10, 12, 13, 16, 18 and 20. Let's say we have something like this, and we have to find, right, where we have to find where we will be inserting okay, let's take some more numbers here. This is 10, right? Let's also take 8 and 10 here, right? Let's say we have to search for 7, right, where will be insert 7, right? So from the array we can see we should insert 7 here at this position 8, but let's also try to find that using binary search, right? Let me take the pen. Here it was 13, right? So now this is 0, 1, 2, 3, 4, 5, 6, 7 and 8, right? So let's calculate the mid. Mid will come out to be 4, right? Now what we will do, we will check this value is less, so we will move towards the left part, so our mid will be pointing at this point. So our mid will become our high will become mid minus 1. So our high will be pointing at this point, which is, the value is 3 here, right? Now we will do binary search in this. So what we will do, we will try to find an element. So here we can see we will be landing at 6, right? This will be our mid, right? Now when this is our mid, what will we do? we will see that this target value is not equal to this, and it is also greater, so we should move towards this part, right? So we have to search within these two parts, right? These are this is what is left, right? So our mid will now become this particular value, that is 8. Now at this particular value, we see that it is greater than 7. We will be storing it inside of our answer, right? And then what we will do, we will move towards the left part, but we can't move towards the left part because now we have exhausted the whole array, right? So this is how we will be able to find the position where we will insert. The position should be just greater than this 7, right? So let's code it. So let's come here and code it. So first let's take the size of the array here, nums dot size, right? Now there are two edge cases also. So the first edge case is, let's say it was 1 that was given to us and we had to insert it. Now 1 is less than the first element itself, right? And the whole array is sorted. So definitely we have to insert 1 at this position only. Similarly, let's say we were given 22, right? We were given 22, right? So if we see the last value, 22 is greater than that. So we can't apply binary search in that case. We will simply return n here, right? That is 9. And here we will simply return 0, right? So let's also consider these edge cases, right? So that is if target value is less than the first value in the array, right? The first value in the array. What will we return? We will simply return 0. Similarly, if target is greater than the last value, that is nums of n minus 1, what we will do, we will simply return n, right? And after that, what we will do? After that, we will be doing our binary search. So first, let's initialize our 2 pointers, that is low and high, right? And also initialize mid, right? Initially mid is at -1, which is no index. So while inside of this loop, right, while low is less than equal to high, we will be calculating mid. So mid is what? Low plus high by 2. Then what we will do? We will check if the particular mid that we have found, if it is equal to target, right? Then we have to simply return it. That means the element exists and we have to return its position, right? So what we will do, we'll say if target equals to the mid of equal nums of mid, right? Then what we will do, we will simply return mid. Otherwise, we have to check else if. Also, let's declare our ans variable here, ans, right? Then we will check if our target is greater than nums of mid. Then what we'll be doing, we will be moving towards the right. Oh, sorry. If the target is greater than mid, then we have to move towards the right. So how do we move towards the right? We will say low should be equal to mid plus 1. But in the other case, when we'll be moving to the left half, then we have to store that particular mid inside of our answer variable, as we saw, right? Because we want the value just greater than, but we will also move towards the left to find if there still exists a value which is just greater than and which is also less than this mid, right? So what we will do, we will say high is equal to mid minus 1. So after doing all this, we will simply return our ans, right? So let's run it. Okay, so it's accepted. So that is how you have to solve this question.